Hello everyone. So welcome again to my another video on AWS Certified Solution Architect Associate exam. So in this video, again I will go through few questions and their answers and explain them step by step. I will also explain why this option is correct and why the other options are not correct. Okay, so let's start the question one by one. We'll go through. Okay, let's start. So the question one says, a company runs workloads on AWS. The company needs to connect to a service from an external provider. The service hosted in the provider's VPC. According to the company security team, the connectivity must be private and must be restricted to the target service. The connection must be initiated only from the company's VPC, virtual private cloud. Okay, so which solution will meet this requirement? Sorry, it is must here, it should be meet this requirement. Okay, now let's go through the option one by one. So the option one says, create a VPC peering connection between the company's VPC and the provider's VPC and update the route table to connect to the target service. Option 2, ask the provider to create a virtual private gateway in its VPC. Use AWS private link to connect to the target service. Number 3, create a NAT gateway in the public subnet of the company's VPC and update the route table to connect to the target VPC. Okay. And number 4, ask the provider to create a VPC endpoint for the target service and use the AWS private link to connect to the target service. Okay, let's see. So what is the correct answer? Ask the provider to create a VPC endpoint to the target service and use AWS private link to connect to the target service. Okay, so let us go through the requirement carefully. So the requirement says the connectivity should be private. Okay, so the connection should not traverse the public internet. Okay, and restricted to the target service only. So it means access should be limited just to that service, specific service, not to the entire provider VPC. And the third requirement was connection initiated only from the company's VPC. So the company should be the one connecting, not the provider. All right. So that is the reason this option is the correct one. Ask the provider to create a VPC endpoint for the target service and use the AWS private link to connect to the target service. Okay. So now let us see the explanation why this answer is correct. Okay. So what does AWS private link provides? So it provides private connectivity between VPC, AWS services, or on-premises network without using public IPs or internet. Okay, so this is the benefit of AWS private link. And it also provides access only to specific service, fine-grained access, unlike VPC peering. Okay, and it is one-way initiation. Actually, the consumer connects to the provider service. Okay, and how it works? The provider exposes the target service as VPC endpoint service, that is a private link service, and the company creates an interface VPC in its own VPC that connects privately to that service. Okay, so this setup ensures no internet traffic. Okay, only the target service is reachable. The connection is initiated only from company's VPC. Okay, so now let's see why other options are incorrect. So VPC peering connection, it allows full bidirectional access between VPC, so it's not meeting requirement and cannot restrict access to the specific service. Fine, so it doesn't meet the restricted to target service requirement. Okay, virtual gateway with private link. So private link doesn't use virtual private gateway, so this is conceptually incorrect. Okay, NAT gateway in public subnet. So you can see here route traffic through the internet, so violates the private connectivity requirement. Okay, so this three requirement, these three options are incorrect. So you got the reason for that. I hope this is clear to you. So now let's move to next question. Already the final answer, it has already been discussed. Okay, now let's move to the next question. Okay, so the now question 2 says, a company runs its two-tier e-commerce website on AWS. The web tier consists of a load balancer that sends traffic to Amazon EC2 instances. The database tier uses an Amazon RDS DB instance. The EC2 instances and the RDS DB instance should not be exposed to the public internet. The EC2 instances require internet access to complete payment processing of orders through a third party web service. The application must be highly available. All right. So, which combination of configuration option will meet these requirements? Okay. So, we need to choose more than one. So, we need to choose two requirements. Okay. So, now let's see what are the options provided. First, use an auto-scaling group to launch EC2 instances in private subnet, deploy an RDS multi-AZ DB instance in private subnets. Okay, number two, configure a VPC with two private subnets and two NAT gateways across two availability zones, deploy an application load balancer in the private subnet. So number three, use an auto-scaling group to launch the EC2 instances in the public subnet across two availability zones, deploy an RDS multi-AZ DB instance in private subnets. Okay, number four, configure a VPC with one public subnet, one private subnet, and two NAT gateways across two availability zones, and deploy an application load balancer in the public subnet. And number five, configure a VPC with two public subnet, two private subnet, and two NAT gateways across two availability zones, and deploy an application load balancer in the public subnet. Okay. So let us analyze the question carefully. What does the question says actually? Two-tier e-commerce company app, web tier to EC2 instance behind a load balancer, and database tier, and Amazon RDS DB instance. So database tier is Amazon RDS DB instance. Okay. So the requirement, EC2 and RDS should not be exposed to the public internet. EC2 needs outbound internet access for payment processing via third-party web service. So, and this should be highly available. So we should do multi-AZ setup. So what should be the correct combination? So we need to keep EC2 and RDS in private subnet, not publicly accessible. Provide an internet access to EC2 via NAT gateways. Okay. And use public subnet only for the load balancer. Okay. This is the main one. Actually, this is the thing which is facing the internet. And we should also have multi-AZ for high availability. All right. Now let's see. Option 1, use an auto-scaling group to launch the EC2 instance in private subnet, as I told you earlier, and deploy an RDS multi-AZ instance in private subnet. All right. Why it is correct? See, EC2 and RDS are both in private. Okay. And multi-AZ RDS, which make it highly available. And EC2 auto-scaling make it scalable. Okay. We will still need NAT gateways for outbound access. Okay, that we'll see when we are using it. So option 2, configure VPC with two private subnet and two NAT gateways across two availability zones. So this is also incorrect. ALB must be in public subnet. Okay. Application load balancer must be in public subnet to receive traffic from the internet. So if we put it in private subnet, so we cannot access internet directly. Okay. Option 3, use auto-scaling group to launch EC2 instance in public subnet across two availability zones. Okay. Why it is incorrect? EC2s are in public subnet, they are exposed to the internet. Okay. So this is also incorrect. That is, it is violating the EC2 should not be exposed to the public internet. Okay. So if you put it in public subnet, so it is violating the requirement. Okay. So now let's see option 4. Configure VPC with one public subnet, one private subnet, and two NAT gateways across two availability zones, deploy an application load balancer in the public subnet. So only one public subnet and one private subnet, it will not make it highly available. So two NAT gateways, but only one private subnet doesn't make any sense. Okay. So now let us see. Yeah, this one will be the correct because we are having two public subnet and two private subnet. Fine. Two public subnet for ALB, application load balancer, which will be facing the internet. Okay. And two private subnet for EC2 and RDS, which will make it secure. Okay. And two NAT gateways that will allow EC2's outbound access with high availability across the ACs. Okay. So option 1 and 5 are the correct in this one. Okay. Fine. So this is the architecture summary. You can see from internet, it will go to application load balancer. Okay. Now then it will go to EC2 auto scaling group in the private subnet, and then NAT gateways. Okay. In public segment for outbound EC2 access. Okay. And the RDS multi-AZ instance in private subnet. So this is the architecture summary. So you can see this meets all the requirement. It is secure, scalable, highly available, and EC2 instance can access the internet safely. Okay, this one. Can you see? Okay, now let's move to question 3. Question 3 says, a company has the highly dynamic batch processing job that uses many Amazon EC2 instances to complete it. The job is stateless in nature, can be started and stopped at any given time with no negative impact, and typically takes upwards of 60 minutes total to complete. The company has asked a solution architect to design a scalable and cost-effective solution that meets the requirement of the job. So, what should the solution architect recommend? Okay. So, option 1 is implement EC2 spot instance. Number 2, purchase EC2 reserved instance. Number 3, implement EC2 on-demand instance. Number 4, implement the processing on AWS Lambda. Okay. So, let's see which option is correct. So, let's go analyze this option, analyze the question actually. So, if we see, the correct answer should be implement EC2 spot instance. What is the reason? See, highly dynamic and stateless and interruptible workloads and batch processing jobs that can be stopped and restarted without issues. Okay. And it also offers 90% of cost saving compared to on-demand pricing. Since it is mentioned that job can be stopped and restarted, so the risk of spot interruption is acceptable. Okay. And it is also cheap. It will save you 90% of your cost. Okay. The spot instance. Yeah. If you need kind of thing which is highly available and reliable, then it is not a good option. Spot instances are not good option. Okay. Since it is already told that job can be stopped and restarted any time, so there is no risk right there taking the spot instances. Okay. So it meets all the requirement, that is scalable, can launch many instances as needed, as I told, and cost effective, use spare capacity as discounted rates. Okay, cost effective, stateless and uninterruptible, perfect match for spot instance. So it is also so as already told, the system can be interruptible. So it can be interrupted. It doesn't matter whether the job can be stopped and restarted at any point of time. Okay, as it is making our system cost effective, so we can go with spot instance. All right. But if you want highly available, then this is not a good option, as I told you earlier. Spot instances are not a good option for highly available. Okay. So purchase EC2 reserved instance. Reserved instances are cost effective only for predictable steady state workloads, not dynamic batch jobs. Okay. This workload is not continuous, so RIs would waste money with instance when instances are idle. Okay, so reserve instance will waste your money when the instances are idle. So actually the job will be not running all the time. Okay, so it will waste your money. They are also cost effective, but not as much as spot instances. So implement EC2 on demand. This is also not works for dynamic job, but more expensive than spot instance. Use on demand only when you can tolerate interruption, not the case here. Okay. And on demand are also quite costly. Implement the processing AWS Lambda. No, Lambda is not suitable for long running jobs. Okay. So it can, maximum execution time is 15 minutes per function for Lambda. Okay. Actually, the batch job that takes approximately 60 minutes in total. That is not good for this. Okay. So final answer, as I told, implement EC2 spot instance. So what the question 4 says? So the question 4 says a company has a dynamic web application hosted on two Amazon EC2 instances. The company has its own SSL certificate, which is on each instance to perform SSL termination. There has been an increase in traffic recently, and the operation team terminated that SSL encryption and decryption is causing the compute capacity of the web servers to reach their maximum limit. So, what should a solutions architect do to increase the application performance? So, option 1 says create a new SSL certificate using AWS Certificate Manager, install the ACM certificate on each instance, create an Amazon S3 bucket. This is option 2, sorry. Option 2 says create an Amazon S3 bucket, migrate the SSL certificate to the S3 bucket, configure the EC2 instances to reference the bucket for SSL termination. Okay. So number 3 says create another EC2 instance as a proxy server, migrate the SSL certificate to the new instance and configure it to direct connection to the existing EC2 instance. Okay, so number 4 says import the SSL certificate into AWS Certificate Manager, create an application load balancer with an HTTPS listener that uses SSL certificate from ACM. Okay, so now let us see which is the correct answer. So the correct answer is import the SSL certificate into AWS Certificate Manager and create an application load balancer with an HTTPS listener that uses SSL certificate from ACM. So let us see the explanation why it is correct. So if you see, currently each EC2 instance is performing SSL termination, that is encryption and decryption. So which is CPU intensive. As the traffic increase, this overhead reduce the available compute capacity for handling actual web application requests. So to offload SSL processing, you should use AWS managed load balancing. So let us see the step-by-step reasoning. So problem 1 says SSL TLS encryption and decryption consumes CPU on EC2 instances. Our goal is to improve performance by moving or offloading the SSL termination task away from EC2 instance. Okay. So what is the solution? The solution says use an application load balancer in front of the EC2 instances. All right. The ALB can handle the HTTPS, that is SSL or TLS termination, freeing the EC2 instances to handle application logic. Fine. Okay. So the SSL certificate can be managed by ACM, that you can import your existing certificate. Okay. So what will be the result with that? So the SSL handshake and encryption or decryption are performed by the ALB itself. EC2 instances received decrypted HTTP traffic, reducing CPU overload. Scaling and certificate management become easier and centralized. So I think you can understand why this option is the correct one, by importing the SSL certificate into ACM. Okay, let us see why the other options are wrong. Now see, if you create a new ACM certificate and install it on each instance, this does not offload SSL from EC2. The instances still have SSL termination. Problem remains unsolved. All right. So if you see, if you are using S3 bucket to store the SSL certificate, see the S3 cannot perform SSL termination or act as a web server or proxy. S3 is mainly meant for storage. It is not meant for the SSL termination or acting as a web server or proxy. Okay, so certificate cannot directly use from S3. All right. So create a proxy of EC2 instance for SSL termination. This is an unnecessary complexity we are adding, and it is also a single point of failure. Okay, we still need to management and scaling effort. Okay, so the final answer: import the SSL certificate into ACM and create an ELB with an HTTPS listener that uses the SSL certificate from ACM. Okay, so this is the correct answer. Fine. So for today, these 4 questions, I think you people have understood. Okay, so that's all for today. Okay, so thank you for watching my video. I hope you like it. Okay, please subscribe my channel and hit the like button. Okay, and if you like it and subscribe it, it gives me enthusiasm to create more videos. So keep watching and just follow up with my next video that I will bring on the same topic, that AWS Certified Solution Architect Associate exam. Okay. Thank you for watching. Bye bye.